What you are looking at are parts that have all been labeled or identified by a process called electrochemical marking. Electrochemical marking is economical, simple, fast, and a safe process for stress-free permanent marking on all conductive metals. In this tape, you'll be shown the principles of electrochemical marking, the different types of electrochemical marking available, and how to produce high-quality markings on a variety of parts and products. Electrochemical marking, also known as electroetching, electromarking, or electrolytic marking, are all one and the same. This process incorporates 5 simple components. They are the power unit, the marking applicator, the stencil, the electrolyte, and the cleaner. The power unit supplies the voltage and current required for the process. This is connected to the marking applicator, also known as the hand pad. The electrolyte is applied to the screen cloth of the hand pad. The stencil carries the information that needs to be marked onto the part. The part is positioned onto a ground plate to complete the electrical current. The etching process starts by placing the hand pad onto the stencil, which rests on the part. Once the electrolyte fills the apertures of the stencil and makes contact to the part, the electrochemical action takes place. The depth and darkness of the etch is determined by what you set on the power unit and how long the pad makes contact. After a short period of time, the hand pad and the stencil are removed and the mark made is visible. The last step is cleaning the part. Cleaning is necessary to remove excess oxides and electrolyte remaining on the part. The result is a high-quality permanent mark which can only be removed by buffing or grinding the metal down to the depth of the mark. Electrochemical marking offers 2 basic types of etch. They are a normal etch and a deep etch. Normal etch produces a dark mark on the metal surface. The depth of the mark can be controlled from 1/10,000th of an inch to 1/1000th of an inch. This type of etching is ideal where positive identification is required with a minimal amount of process time, or in situations where changes in surface conditions are not tolerable. Deep etch can produce a mark of just a few mils to up to 10 mils deep. This can be useful in applications where absolute traceability of a part is required, or where further processing of a part would cover over surface-type markings. Here are some examples of how to produce a normal etch on varying size, shape, and type of materials. The first step is setting up the power unit. Plug the line cord from the power unit into a 110-volt AC outlet. On the front of the power unit are the controls for power on-off, AC-DC, and normal etch deep etch. The meter indicates the level of amps being used while etching, and below it is a control for current regulation. On the lower panel are the outputs for the etching tools. In most cases of normal etching, the AC-DC switch is set to AC. However, when normal etching aluminum or metals with a black oxide, the DC setting should be used. The AC setting, or alternating current, alternately etches out and redeposits a combination of the metal oxides and electrolytic salts, producing a black mark. The DC, or direct current position, is generally used with the deep etch setting. The DC setting charges the marking applicator negative, which dissolves metal out, etching a frosted or clear mark. For normal etching, the normal etch deep etch switch is set to normal etch. And for most cases of normal etching, the rheostat should be set to 5 to start with. There are two different types of hand pads used for etching. One uses a screen cloth, and one uses a wick. For normal etching, the screen cloth hand pad is used. Fasten a clean screen cloth onto the hand pad before starting. There are also larger and smaller hand pads available to satisfy the different sizes of marks required to be made. Attach the black cord into the hand pad and plug the opposite end into the black mark receptacle on the power unit. One useful tool in etching is the stencil cleaner tray. The stencil cleaner tray serves many functions. One is to clean and replenish the hand pad with fresh electrolyte. Another is to remove oxides out of the apertures of the stencil, which can occur after extensive use. The stencil cleaner tray can be used for the deep etch hand pad as well. Connect the stencil cleaner tray to the power unit with the yellow cord. Plug one end into the cleaner tray and the other end into the yellow cleaner receptacle on the power unit. The red cord is used for connecting to the ground plate. This can be the plate mounted onto the door of the kit or one of your own. Plug one end of the red cord into the ground receptacle on the power unit. The alligator clip-in is attached to the ground plate. Or, in cases with larger parts, it can be directly attached to the part. In either case, it's important that the clip and whatever it's attached to are kept clean to ensure good electrical contact. Next is selecting the electrolyte. The electrolyte chart lists many types of metals, alloys, and platings that are most commonly etched. Next to each listing is the recommended electrolyte to be used for normal etch as well as deep etch. Also listed is the power unit setting and special instructions that may apply. In cases where more than one electrolyte is shown, it's recommended to try the first one listed, then the next if not satisfied. For the first example, the material is 300 series stainless steel. The recommended electrolyte under the normal etch column is MSC1. Your kit contains the three most commonly used electrolytes. However, if the material you are working with requires a different type of electrolyte than supplied, they are readily available for marking methods. Apply MSC1 electrolyte to the screen cloth of the hand pad. Add enough electrolyte to the cloth to bring it to the point of saturation, but not dripping wet. Blot off the excess electrolyte onto a paper towel. Remove enough electrolyte to the point where the towel starts to show dry patches. Also apply MSC1 electrolyte to the stencil cleaner tray wick. Always use the same electrolyte in the stencil cleaner tray that's currently being used on the hand pad. And by the way, these electrolytes are pH balanced, buffered salt solutions. They are completely harmless to skin, clothing, parts, and surrounding equipment when used as directed. The last item needed for electrochemical marking is the stencil. The most commonly used stencil is the DF stencil. This type of stencil is produced photographically, providing the ability to match any design, logo, or special letter style. The DF stencil also has an extremely long life, producing up to several thousand marks. Another type of stencil used is the die impression stencil. This stencil is made specifically for the customer to process in plant, giving him the ability to meet short-run requirements, or in cases where frequent changes in labeling are made. The die impression stencil can produce up to 50 good quality normal etch type markings. However, because of the stencil's composition, it's not recommended for deep etching. In most cases of etching, the stencil is laid directly on the part to be marked. This is especially true in situations where locating the stencil information on the part is critical. However, in cases where the mark's location is less critical, the stencil can be attached directly to the screen cloth. Then the application of the handpad and the stencil are made in one easy step. For this type of marking, the retainer ring is used to hold the stencil in place to the handpad. Note that the stencil should be attached to the handpad so the legend reads reversed. Position the stencil onto the part to be marked as called for by your controlling documentation. Next, switch on the power unit to make the mark. The voltage supplied to the handpad is very low and represents no shock hazard. Gently but firmly set the handpad down on the stencil while holding it in place with your finger. Blot over the legend to be marked several times, lifting the handpad about every 1 to 2 seconds, then lift off the stencil to view the mark. Immediately after the mark is made, the part should be cleaned. Apply a small spot of APC cleaner to a soft cloth. Rub over the etched area with the cleaner, then wipe off any remaining cleaner with a second cloth that is dry. The result is a high-quality mark that took just a few seconds to do. Here's another example for normal etching. This time the material to be etched is Inconel 750 series. The proper electrolyte to be used is MSC4. Since the electrolyte to be used is different than the one last used, the screen cloth and the cleaner tray wick should be changed. Attach a clean screen cloth onto the handpad. Apply a generous amount of MSC4 electrolyte onto the handpad screen cloth. Then blot off the excess electrolyte onto a paper towel. At the same time, the cleaner tray wick should be changed. Blot off any electrolyte remaining on the tray with the paper towel. Place the clean wick onto the tray and add MSC4 electrolyte. For this example, the stencil can be positioned directly on top of the part the same way shown earlier. However, a faster and more precise method is to use a holding fixture custom made for the part. This can be especially useful where a large number of parts need to be marked. Using this configuration, the actual etching process is unchanged. Again, switch on the power unit if it is off. The setting should still be AC and normal etch, with the rheostat at 5. Set the handpad firmly on the stencil, frequently lifting and changing its area of contact. One more advantage of a holding fixture is the stencil can be lifted off the part to check the progress of the etch. Then the stencil can accurately be repositioned over the mark and etching can continue. Once the desired mark has been made, remove any remaining electrolyte with the APC cleaner. Then wipe off the cleaner with a clean, dry cloth. The next normal etch example is a little different. Here the stencil information is to be marked onto the diameter of the part. The material is again Inconel 750 series. Since the electrolyte remains the same, the screen cloth and cleaner tray wick do not need to be changed. For this particular example, it's easier to hold onto the part while etching. This makes it necessary to attach the ground clip onto the part to be marked. The stencil is wrapped around the part in the location called for on the drawing. It's important when using this technique not to stretch the stencil around the part, as this would distort the legend. Once set, the hand pad is replenished with fresh electrolyte, the power unit switched on, and the etch is made. Again, as soon as etching is finished, wipe off any remaining electrolyte with the APC cleaner. Then dry with a clean cloth. Next, the second part of the legend can be marked. The stencil is positioned onto the part as called for by the drawing. Then the second part of the etch is made. For all of these examples, you may have noticed that the hand pad is always returned to the plastic tray. This is done for a couple good reasons. If the hand pad was set down on the ground plate, it would short out the power unit. It will also make a good size etch in the plate as well. It's always a good practice to return the hand pad to the plastic tray each time when you're done etching. After the second mark is made, the part is re-cleaned with the APC cleaner. Each time you clean a part, use a different spot on the cloth with fresh cleaner applied. Also be aware that any electrolyte that gets on your fingers will also get transferred onto the parts you are handling, which can leave stain marks on those parts if not removed. It's a good practice to wipe off any electrolyte that may get on your hands as soon as possible to avoid this problem. The next examples will be on deep etching. As mentioned earlier, the deep etch hand pad is used for this process. Instead of using a screen cloth, this hand pad uses a wick, which is designed to hold more electrolyte which is necessary for the process. The wick is held in place with a retainer ring. Hookups for deep etching are the same as before. One end of the black cord is plugged into the black mark receptacle on the power unit. The other end is plugged into the back end of the deep etch hand pad. The red cord is connected to the ground receptacle on the power unit, with the other end attached to the ground plate or the part being etched. And again, the yellow cord is plugged into the yellow cleaner receptacle on the power unit, with the other end plugged into the stencil cleaner tray. The power unit should be set to DC in deep etch. For this first example, the rheostat is turned down to 3 because the stencil information is fairly small. The material to be etched is 300 series stainless steel. The proper electrolyte to be used, listed in the deep etch column, is MSC1. Apply MSC1 electrolyte to the wick on the hand pad. Add enough electrolyte to the wick to bring it to the point of saturation but not dripping wet. Remove any excess electrolyte by blotting on a paper towel, but to a lesser degree as was done for the screen cloth. Also place a clean wick onto the stencil cleaner tray and apply the same electrolyte to it. For this first deep etch example, the mark is to be made around the diameter of the part. Since it's easiest to do this while holding on to the part, the ground clip again will be attached directly to it. The stencil is located onto the part as specified by the controlling documentation. The power unit is switched on and etching is ready to begin. While making a deep etch, it's important to keep two things in mind. One is that only light pressure is needed for this operation. Once the electrolyte makes contact with the metal, the etch immediately begins. Pressing hard will only squeeze the electrolyte out of the wick, slowing the etching process. Second is to lift the hand pad up momentarily to allow the gases and steam to escape from underneath the stencil. This is especially necessary when deep etching due to the higher current involved. Once the etch is made, remove the leftover electrolyte with the cleaner. When cleaning a part that's been deep etched, it's important to rub over the mark firmly to remove all the electrolyte out of the etch. After cleaning, you may notice a haze or halo effect around some of the characters. This is normal and again is due to the higher current and more electrolyte used to make the etch. Rubbing over the mark with a piece of Scotch-Brite will quickly and easily remove the halo effect. Here is another example of deep etching. This time the part is made out of aluminum. The proper electrolyte to be used for deep etching aluminum is MSC1. Again, since MSC1 was just used for the last example, the wick on the deep etch hand pad and the stencil cleaner tray do not need to be changed. Since the character size for the stencil to be used is fairly large, the rheostat is turned up to 5. Also, the ground clip is reconnected to the ground plate since the part can be etched in a normal fashion. The stencil is located to the part where the information is required to be marked. The excess length of the stencil is wrapped around the part to help hold it in place. Once set, the power unit is switched on, the hand pad is cleaned and replenished with fresh electrolyte, the excess blotted off, and the etch made. Again, light contact is made with the hand pad, frequently lifting and letting steam and gases escape, and fresh electrolyte to fill in the stencil apertures. Also note that each time the hand pad is lifted, it's set back down using a different area of the wick. This is so all of the available area of the wick is used and lessens the amount of times for replenishing. After a minute or so of etching, the stencil is removed to view the etch. Here, the desired depth of 1 to 2 mils has been reached. The part is cleaned thoroughly with the APC cleaner, then wiped dry with the second cloth. The last etching example will be made using the bench fixture. The bench fixture works the same as the normal etch hand pad, but is inverted. Instead of placing the stencil and marking applicator onto the part is placed onto the stencil with the marking applicator underneath. Then the hand ground is set on top of the part to complete the electrical connection. The bench fixture allows for fast and precise location of a part to the stencil legend. Custom locating plates are also available for a variety of sizes and shaped parts. It should be noted that the bench fixture is to be used for normal etch requirements only. The setup for the bench fixture is similar to that of normal etching. Since the bench fixture takes the place of the hand pad, the black cord now plugs into the receptacle on the back of the fixture. The opposite end of this cord is, as always, plugged into the black mark receptacle on the power unit. The red cord is disconnected from the ground clip and is plugged into the receptacle on the hand ground. The opposite end is plugged into the red ground receptacle on the power unit. The cleaner tray is not used for this type of etching. For this example, a custom-made locating plate will be used to hold the part in alignment with the stencil information. On top of the bench fixture is the wick pad. It's held in place with the retaining ring. It can easily be removed and replaced when it becomes dirty or different electrolytes need to be used. The part used for this example is made of 750 series Inconel. The correct electrolyte to be used listed in the normal etch column is MSC4. Saturate the wick with the electrolyte, then blot off the excess with a paper towel. The stencil is aligned and taped down to the locating plate. Then the plate is mounted onto the bench fixture. Now the legend should read reversed. Tighten down the nylon wing nuts to hold the plate securely in place. The power unit settings are again what normally would be used for any normal etch type marking. The normal etch deep etch switch is set to normal etch, and the AC/DC switch is set to AC as called for on the electrolyte chart. The rheostat is set to 5, which again is most commonly used for normal etching. Once everything is set, the part is securely placed onto the locating plate. The power unit is switched on and the hand ground is set onto the part to start the etch. The dwell time for the etch will be 2 to 5 seconds or more depending on the amount of information to be marked. Again, after the mark is made, remove the remaining electrolyte with the APC cleaner, then dry off with a clean cloth. The result is a high-quality mark equaling that of a normal etch hand pad with perfect centering of the stencil information every time. The following are a few examples of common problems you may experience in electrochemical marking. One is blotting over a part to make a mark and get no results. If this happens, the first thing to check is the power unit is switched on and the indicator is lit. Second, check that the ground clip is firmly attached to the part or ground plate, whichever the case may be. Also check that the part itself is clean and is making good contact to the ground plate. If this doesn't resolve the problem, the trouble usually is in the cords. This can quickly be checked at your bench. First, turn off the power unit and turn the rheostat down to 1. Set the AC/DC switch to AC and the normal etch deep etch switch to normal etch if not already there. Disconnect the black cord from the hand pad and plug into the red ground receptacle on the power unit. Now switch on the power unit and slowly increase the rheostat setting while shaking the suspected cord. The meter should hold steady for each setting on the rheostat. Then promptly turn down the rheostat and switch off the power unit. The red cord can be tested the same way. Disconnect the black cord and return the red plug back to the red ground receptacle. Plug the other end of the red cord into the black mark receptacle. Switch on the power unit again to test the red cord. Here the meter indicates that the cord is intermittent. Switch off the power unit and replace the bad cord. If the meter failed to respond with either cord, then the power unit may be at fault. In this case, it should be returned to marking methods for repair. It should be noted that these connections made to the power unit should only be used to test the etching cords. Under no circumstances should the power unit be on longer than a few seconds to perform each test. Occasionally, you may experience trouble where not all of the stencil information is being marked onto the part. This is usually due to dirt or photoresist blocking part of the stencil aperture. This can easily be removed by blowing out the blockage onto a scrap piece of metal. Switch on the power unit and set it to DC and deep etch. The rheostat should be at 5. Set the stencil onto a piece of steel or aluminum and blot over it several times with the deep etch hand pad. The type of electrolyte used can be whatever you have on hand. After blotting, the debris should be removed. If not, it may be necessary to repeat this step a few more times to clear the stencil. Another problem you may encounter is how to clean the stencil used on the bench fixture if it becomes clogged, since the cleaner tray is not used. It can be cleaned with the tissue moistened with the current electrolyte being used and rub over the clogged area. At times, you may need to realign the stencil to finish marking a part. Sometimes it's helpful to use a drop of the currently used electrolyte over the stencil to help see through the underlying mark. There are two other types of etches available using the Mark 300 power unit. One is a deep dark etch. A deep dark etch starts out as a deep etch, with the power unit set to DC and deep etch. After the deep etch is made, the power unit is switched to AC and normal etch. The hand pad is blotted over the stencil a few more times to fill in the deep etched area. The other type of etch is a DC normal etch. Using the normal etch hand pad, the technique is similar to normal etching. The result is a frosted or clear mark of just a few tenths of a mil deep. One of the most common misunderstandings in electrochemical marking is how long a dwell time to use. This is especially true when deep etching. Here's an example where the dwell time for a deep etch was approximately 30 seconds. Using too long of a dwell time will generally have poor line definition with part or all of smaller characters missing. Here's the same etch with a dwell time of approximately 10 seconds. It should be noted that the proper dwell time is relative to the size of character and amount of legend to be marked. Larger characters and more legend will require a longer dwell time. Both of these examples were made with the rheostat set at 5. Changing the rheostat mainly affects the sharpness of a mark, but will also have some effect on the dwell time. Here is an example of a deep etch where the dwell time is approximately 20 seconds with the rheostat set at 5. Here is the same mark with the same dwell time, but made with the rheostat set at 2. When a deep etch of 5 mils or more is required, it's usually best to use a lower rheostat setting. This is especially true with small-sized characters. Although using a lower rheostat setting will lengthen the dwell time, it will hold the mark to a finer line definition. Whenever the proper power settings are uncertain, it's always best to perform a few test marks on scrap parts or pieces of metal of similar material. And one last tip, after extensive use, the deep etch hand pad can become loaded with metal oxides and salts. This can easily be sanded off with the 400 grit piece of sandpaper. This technique can also be used on the bench fixture should it need it. Cleanup after etching is as important as any other step. Remove all wicks and screen cloths from their hand pads, including the wicks on the bench fixture and cleaner tray. The deep etch wicks normally are not reusable and should be disposed of. Rinse off the screen cloths and wicks under running water. Rinse off the hand pads with your finger over the receptacle to prevent contamination or corrosion from building up inside the connector. Rinse off the bench fixture and cleaner tray the same way with your finger covering the receptacle. Allow for the tools and wicks to dry before reusing. With the APC cleaner, wipe off the ground plate and any other items that may have come in contact with the electrolyte to prevent corrosion. Disconnect all cords from the power unit and neatly fold up and return to the plastic storage box. Return all caps to their respective bottles. Clean or wipe off the power unit. Then close up the etching kit. Again, cleanup is an important part of electrochemical marking. Following these simple steps will ensure long life of the tools and kit and will make it much nicer to use for the next person.